Question 15. We're given information about two rockets. Let's call the first one Rocket 1. It starts from a position of negative 7i plus 9j minus 5k and has a velocity of 5i minus 4j plus 2k. Each rocket leaves a trail of smoke, and though the rockets do not collide, their smoke trails do intersect. For Rocket 1, its position at any time will be its start position, negative 7, 9, negative 5, plus the time it's been travelling for times its velocity vector, so that's 5, negative 4, 2. The smoke trail that it leaves will be R1 equals negative 7, 9, negative 5 plus lambda 5, negative 4, 2. If we now consider Rocket 2, the position of the rocket, R2, is negative 6, negative 5, 2, which is its initial position vector, plus t times its velocity vector, which is 9, 6, negative 3. Its smoke trail would be negative 6, negative 5, 2 plus mu 9, 6, negative 3. Perhaps we should call this 1s to indicate it's the smoke trail, and this 2s. We're told that the rockets do not collide, but their smoke trails do intersect. We want to find the coordinates of the point at which the smoke trails intersect. So we want the intersection between these two lines. Equating I components, we get negative 7 add 5 lambda is negative 6 plus 9 mu. For j components, we get 9 minus 4 lambda is negative 5 plus 6 mu. And then for z components, or k components, negative 5 plus 2 lambda is 2 take 3 mu. Let's call these 1, 2, and 3. I've taken the first two and solved them using my calculator. Gives me lambda is 2 and mu is 1.
Using the simultaneous equation solver, so we'll find that in the keyboard, 2D, and we need to be on this one. This is the simultaneous equation solver. So I have negative 7 add 5 lambda, I'm just going to call lambda x because it's easier, equals negative 6 plus 9 mu, which I'll call y. Then I have 9 take away 4 lambda equals negative 5 add 6 mu. We're solving for x and y. Press execute and we get our solutions.
I'm just going to check that this works with the third equation. So, negative 5 add 2 lambda is negative 5 add 4 which is -1, and 2 take away 3 times 1 is also -1, so this works. And we know that they do intersect when lambda is 2 and mu is 1. Substituting lambda is 2 back to here, we get -7 add 2 times 5, giving me 3. 9 take away 2 times 4 is going to give me 1. And -5 add 2 times 2 gives -1. In part B, we're asked to find the shortest distance of rocket 1 from the smoke trail of rocket 2 3 minutes after firing. So that's t equals 3. So R1 will be at position -7 add 15, so that's 8. 9 take 12 is -3, and -5 add 6 is 1. So we want the shortest distance from this point to this line. So here we have 8, -3, 1, and this is the smoke trail for rocket 2. So we know this is going in a direction of 9, 6, -3. We want the shortest distance, which is when this is a right angle. This point here, for some mu, has coordinates -6 plus 9 mu, -5 plus 6 mu, and 2 take away 3 mu. So this vector here, going from this point to this one, will be -14 plus 9 mu. That takes us from 8 to -6 plus 9 mu. Then we get -2 plus 6 mu, and then we get 1 take 3 mu. So we need the dot product of these two directions to be 0. So that's -14 plus 9 mu, -2 plus 6 mu, 1 take 3 mu, dot 9, 6, -3. Actually, I'm just going to divide that and make it 3, 2, -1 is equal to 0. And you can solve this on your calculator.
We want to solve an equation that involves the dot product. Start with Action, Advanced, and Solve. If you go to Category and D, down here we'll find dot P, which is our dot product function. So we need to scroll down a bit to find this. Sometimes it's better to start at E and go in the other way. This is the one we want, so we'll put that in here. Then we need to input our vectors. So we need to go to 2D and Calc. Click on this one and again put a comma in, this one and again, close bracket, equals 0, close bracket. Now we just need to put the vectors in. I'm going to call mu x. So I have negative 14 plus 9x. Then here, negative 2 plus 6x. And then here, 1 take away 3x. This is 3, 2, negative 1. Press execute and it solves it for us.
Solving gives me mu is 1.119 and so on. That establishes this point as 4.0714, 1.7143, and negative 1.3571. Then the distance from here to here is the square root of 8 take away 4.0714 squared plus negative 3 take away 1.7143 squared plus 1 plus 1.3571 squared, giving me 6.5744.